Hi there, folks. Today we're looking at an introduction to quadratic functions, specifically the graphs of quadratic functions. And remember, quadratics are kind of defined by having the x squared in them. And so they're a little bit different than anything else we've graphed so far. A lot of the things we've graphed have been based on lines and the idea of slope and that kind of stuff. And so we have to start to break away from that idea and graph things in a little bit of a different manner. Okay, so when we graph a quadratic, it gives us something called a parabola. So this is a U-shaped curve. All right, so a U-shaped curve that results from a quadratic, that's a parabola. All right, so when we graph quadratics, we get these U-shaped curves that kind of look like this. All right, so it's not going to be linear anymore. We're not going to have slope, that kind of stuff. All right. So when we're graphing those, when we're trying to find this parabolic curve, this parabola that's the graph of our quadratic, the most important point that we need to find is the vertex, all right? The vertex is the highest or lowest point on the parabola. It's the point right here, if I go back to this previous example, at kind of the very tip of the parabola at the bottom, or if it's a parabola that opens down, that's what makes it a maximum, because now that tip is at the very top. Okay, so that's the vertex, and that's kind of where this thing originates from. All right, so like when we graphed lines, we would always start with the y-intercept. When we graph a parabola, we need to find the vertex. It's the most important kind of defining characteristic piece of this curve. We also have this thing called the axis of symmetry, which basically just means this thing is broken into two halves that are identical, all right? There is kind of an invisible line that goes right down through the center of this thing that makes each piece, each half of the parabola, a mirror image of itself. And we've seen the vertex and the axis of symmetry in one graph that we've done before, and that was the absolute value. Remember, the absolute value was a v that was the same on each side. But again, because it was based on a line, we used a lot of slope when we're talking about absolute value, but it still had a vertex that we would find, and it still had an axis of symmetry, a line that cut right down through the center. Okay, we didn't use the axis of symmetry very much with absolute value, but we'll use it a lot more with parabolas. Okay, so if I look at something like this guy, and with anything that we've ever graphed, we always start with kind of this most basic version, and we plot it doing an XY chart, all right? And we'll keep doing XY charts until we can see if there's some kind of pattern or some way that we can graph it without doing an XY chart. So my classic values that I choose for this are probably -2, -1, 0, 1, and 2. Those are my go-to, and they're not always going to work. I'll sometimes have to choose more points, but I'm going to start with these. So if I plug a -2 in there, -2 squared is a +4. And again, when you plug it in, you're plugging it in parentheses. So make sure you do that on your calculator. If you plug this into a calculator, it's got to be -2 in parentheses squared, okay? Or it's not going to give you the right answer. Then I plug the -1 in, again, -1 parentheses squared is a +1. 0 squared is a 0, 1 squared is a 1, and 2 squared is a 4. And so I go ahead and plot these things. Got this guy, -2, 1. And as you're looking at this, you might go, hey, it kind of looks like a V, but think about it this way. If I were to connect these with a line and make the line straight, see how it would miss that third point over on this side? And the same thing would happen if I was going this way. It would miss that third point if I used a line to connect these. So it can't be a line. It's got to be a curve of some kind because the steepness kind of changes as we move on, okay? So, and I could keep going. I can plug a 3 in here and get a 9, or a -3 in and get a 9. And see, that would give me my next ordered pair. Should be up here somewhere. All right. And so again, hopefully when you're looking at this, you can kind of see the pattern that we're coming up with here. But think about it, the defining characteristic of a quadratic is the fact that it's got a squared term in it, so an x squared. And then look at the values here. Isn't this 1 squared, 2 squared, 3 squared? If I went to 4, wouldn't it be a 16? And so we're trying to kind of start to think about the pattern that emerges here, all right? So keep that in the back of your mind. The vertex this time, just looking at our graph, looks like the ordered pair is 0, 0. All right, it's right there at the very center of this thing. And then the axis of symmetry, if you were to kind of look at this thing and say, okay, if I want to cut this thing in half, I'd have to draw a line right here. And notice I'm drawing a dotted line because this line isn't actually there in the sense that we see it. It only exists as kind of a tool in the background, all right? And that's a vertical line, which is an x equals line. And in that case, the equation of that line is x equals 0. All right. So when the line is on the y-axis, it's the equation x equals 0. So that's our vertexes and our axis of symmetry. And really, it wasn't that hard to graph this thing using an xy chart, but eventually we want to see if there's a pattern that can get us away from the xy chart. Okay. So let's look at another one, but let's change it a little bit. So here, if I look at something like this guy, x squared minus 4. Again, I'm going to start off with my standard xy chart, -2, -1, 0, 1, and 2. And now I plug away. -2 squared is a 4, minus 4 is a 0. -1 squared is 1, minus 4 is a -3. 0 squared is a 0, minus 4 is a -4. 1 squared is a 1, minus 4 is a -3. 2 squared is a 4, minus 4 is a 0. And so I plot this thing. So let's see, I've got -2, 0 is right here. I've got -1, -3 is down here. I've got 0, -4, 1, -3, and 2, 0. And if you're looking at this thing, okay, well, that kind of looks like how it did before. And again, if you wanted to keep going, you could plug a 3 in and go the other way at -3. Either one of those gives me a 9. So 3, or sorry, not 9. 9 minus 4, which is a 5. Crazy, Mr. Jansen. A 5. So that would be 3, 1, 2, 3, 4, 5 right here. And then I would have another point here. Okay. And, the reason I kind of just talked about extending that previous graph, even though we didn't need it, is because when you look at this, hopefully you see that it's kind of the same pattern. When we look at this guy, if you were to count from the vertex, you see the pattern is over 1 and then up 1. And then it's over 2 from the vertex, up 4. It's over 3 from the vertex, and then up 9. It's over 4 from the vertex, and then it'll be up 16. It's those squared terms. Well, here it's the same thing. It's the same shape. See, if you counted from the vertex, it would be over 1, up 1. If you counted from the vertex, it would be over 2, up 4. From the vertex, it would be over 3, up 9 if you counted. Okay, so this thing has the same pattern, it has the same shape, so that we should start thinking about, because that might help us graph this thing without an XY chart at some point, okay? And so when you compare this one and the previous one, hopefully you notice that the only difference is that this thing is moved in terms of the vertex, all right? It's moved down 4 units to 0, -4. The axis of symmetry is at the same place, x equals 0. See, that dotted line is still at the same spot, right down through the middle, right down through that vertex, okay? If I looked at this guy, now I've got a +2 here. So again, I'm going to start off the same way, because why not? Whoops, 1. And I plug away. -2 squared is a 4, +2 is a 6. -1 squared is a 1, +2 is a 3. 0 squared plus 2 is a 2, a 3, and a 6. And so I plot these. -2, 6. 2, 3. And so once again, I should recognize that that is the same pattern that I've graphed at this point 3 times. Okay? And notice this is no different than the last 2 examples, except it's moved up this time instead of down. And so the only thing that has changed is the vertex is now at 0, 2. The axis of symmetry is still at x equals 0, right down through the middle. But again, think about the pattern here going from the vertex over 1, up 1. From the vertex over 2, up 4. And you can probably take a guess, from the vertex it would be over 3, up 9. All right, the pattern is those squared values, those perfect squares in terms of how far up I go with how far over I go, okay? If I look at this one, again, start off the same way, ready? Now this one's a little bit different because I plug in and I do the addition first and then square it, because look where the parentheses are. So -2 plus 2 is a 0, and then when I square that, it gives me a 0. -1 plus 2 is a 1. Square that, I get a 1. 0 plus 2 is a 2. Square that, I get a 4. 1 plus 2 is a 3. Square that, I get a 9. 2 plus 2 is a 4. Square that, I get a 16. And now I start to plot this thing. Ready? -2, 0. -1, 1. 0, 4. 1, 9. I'm running out of real estate here. 216 is off my graph. I can't even plot it. Well, this doesn't look like a parabola now, does it? All right. So either Mr. Jansen lied and not all quadratics gives us parabolas, or there's something that we're missing here. All right. And since Mr. Jansen would never lie to anybody, there must be something that we're missing here. I probably need some more points. And as you look at this thing, as I went to the right, I see that this thing has really started increasing a lot. It's going way up over here, right? So maybe I need to choose more points heading towards the left. So maybe I need things like -3, maybe -4. I could keep going, maybe a -5, okay? To kind of see what this thing looks like going the other way. Because the problem is I don't have a vertex right now, and I can't graph this thing without a vertex. So I have to keep plugging in points till I find the vertex, all right? So if I plug a -3 in there, -3 plus 2 is a -1, square that and I get a 1. And when I plug a -4 in, that gives me a -2, and I square that and I get a 4. And then a -5 plus the 2 is -3, I square that and I get a 9. And so going back the other way now, I have a point here, I have a point here, and it looks like I have a point up here. And so now I can see that this is a parabola. I can even see that it still has the same shape of the previous parabolas that I've graphed. Nothing has changed in terms of the shape, but now this thing has moved to the left. And now the vertex is at -2, 0. Which means now the axis of symmetry is at a different place. Watch this. If I cut this thing in half, it's this line right here. Well, that's the line x equals a -2. It's the vertical line that goes through -2. Okay? And hopefully you're starting to recognize that there's a relationship between the vertex and the axis of symmetry in terms of the x values. All right? Then how about this guy? If I look at this thing again, I'll probably start off the same way, -2, -1, 0, 1, and 2. And I plug away. -2 minus 3 is a -5. Square that and I get a 25. -2 minus 3 is a -4. Square that and I get a 16. 0 minus 3 is a -3. Square that I get a 9. 1 minus 3 is a -2. Square that I get a 4. 2 minus 3 is a -1. Square that and I get a 1. And let's plot these. -225 is off the graph, so is -116. So I'm going to start with 0, 9. Which is up here. Even that is a little bit off my graph. 1, 4, 2, 1. And so I'm looking at this thing thinking, once again, either Mr. Jansen's a liar or I'm missing something. Well, it's probably that I'm missing something. So this time, think about which direction you might want to keep going to try to plug points in. Do I want to go to the left or the right? And so it looks like to the left, this thing is just kind of getting bigger. So maybe I go to the right a little bit further. So I try a 3, maybe a 4, even a 5, okay? And if I plug a 3 in, 3 minus 3 is 0, squared, I get a 0. 4 minus 3 is a 1, squared, I get a 1. 5 minus 3 is a 2, squared, I get a 4, okay? And so I get 3, 0 right here, I get 4, 1, and I get 5, 4. Now I can see the vertex. I can see that this thing is the parabola that I've graphed 8 million times, but it's in a different location. And look, the pattern is still there from the vertex. It's over 1, up 1. Over 2, up 4, over 3, up 9, over 4, up 16. So this pattern has recurred in every single one of these examples. So think about how we can use that to graph these things without an XY chart. If that same pattern exists, all I have to do is know where the vertex is, and then I can use that pattern to graph it. Okay? So this time the vertex is at 3, 0. It's moved to the right 3 units. And so I get x equals 3 for the axis of symmetry. And if you haven't figured it out by now, the axis of symmetry is always x equals the x value from the vertex, because the line that cuts this thing in half always goes through the vertex. Okay? And so the question here is, what happens when you add or subtract from different parts of the function? And so when you look back at the previous examples, there were two things that happened. I had like y equals x squared, and then I added to the outside right here. So I added something here. And then I had a version where I kind of added inside with x. I said, you know what, there's x squared, and I added or subtracted inside here, okay? And so what happened was, and hopefully you recognized it, in this scenario, when I added, the graph moved up that many units. Oh, that is a terrible M. Let me try again. I tried to fix it, and it just didn't work. So this moved up that many. And when I subtracted from that value on the outside, the function moved down that many units. And that's kind of how we came up with our new vertex. And then what happened over here, this one's a little bit trickier. When you look at this guy, here's where I added, here's where I subtracted, and notice it moved the whole parabola to the right. Here's where I added, and it moved the whole parabola to the left. And so that should tell us right here, when I do this thing, if I add, it moves this thing to the left, that many. And if I subtract, it moves this thing to the right that many. And so the advantage of knowing this is if I just see what's being added and subtracted, all I have to do is move the vertex, and then I can use that pattern that we've been seeing to graph it. So if I look at this one, again, I'm going to start with an XY chart, -2, -1, 0, 1, and 2. And I plug away. Let's see, that gives me a 4 times 2 is an 8. This one gives me a 1 times 2 is a 2, 0, 2, and an 8. And so this time, we've got our vertex here at 0, 0 again, if you can kind of see that the values in the table are symmetrical. But let me plot these. -2, 2, or -1, 2, 0, 0. And so this one, unlike the rest of them, that is not the pattern we signed up for, right? That's not the pattern we're used to. The pattern was from the vertex over 1 up 1, over 2 up 4, over 3 up 9. But this one, it's over 1 up 2, and then over 2 up 8. Do you see what's happened to our pattern? It's being multiplied by 2 because that's the A value. And so that value out front, we call it the A value, the thing that's in front of the x squared. It basically multiplies this thing, all right? So it multiplies the height. And so in this one, the vertex is still the same. The axis of symmetry is still the same. The thing that changes when I change that value out front, instead of having a 1, the shape changes, okay? And so if you look at this one, maybe you want to take a guess at this one. Maybe you've noticed that, hey, this one's going to have a vertex at 0, 0. And then I know the pattern from all those other parabolas was over 1 up 1. But if I have a 3 out front, instead of going up 1, I'm going to go up 3. Instead of going over 2 up 4, instead of going up 4, I'm going to go up 12. And it's the same thing in the other direction. And so I get this parabola that's even skinnier than the previous one because it's being stretched vertically is how we describe this, okay? And I can go back and fill in the XY chart here. But the idea is we want to try to get away from the XY chart. So we're trying to figure out, okay, how does putting that thing out front change this thing? Well, if I do the old -2, -1, 0, 1, and 2, let's check to see how well I did over here. If I plug a -2 in there, that gives me a 12. If I plug a -1 in there, that gives me a 3. If I plug a 0 in, if I plug a 1 in, if I plug a 2 in, and look at that, those are the points that I already plotted without doing the XY chart, okay? So by just changing the pattern by multiplying by 3. And so in this one, apply the same kind of thing. If I put a 1/2 out, I'm still going to have the same vertex, but think about how that's going to affect this thing. Instead of over 1 up 1, I'm going to go up half. Instead of over 2 up 4, I'm going to go up half that amount, so 2. Instead of over 3 up 9, I'm going to go up half that amount, so 4.5. Instead of over 4 up 16, I'm going to go up half that amount, so it's going to be 8. Instead of over 5 up 25, I'm going to go up half that amount, so I'm going to go up 12.5. And it's the same thing going this other direction, okay? And see, this is where the axis of symmetry comes into play. I'm plotting these guys basically by reflecting them. And so I get this parabola that looks wider than all the previous parabolas because it's being shrunk vertically. And again, I'm going to go back and fill in the XY chart and hopefully understand. You could do an XY chart every time if you want, but you have to hunt around for the vertex then, okay? By understanding these shifts and saying, hey, when I add or subtract, it moves it left, right, up, and down, okay? I can figure out what the vertex is and then do your XY chart from there, okay? but I don't need the XY chart at all if I understand how that value out front affects things, okay? So now if I plug the 2 in there, that gives me a 4 times 1/2 is a 2. If I plug a 1 in, that gives me a 1/2. If I plug a 0 in, a 1 and a 2. And look, that matches the points that I've already plotted. And if I kept going, I'd get the same things, okay? So try to figure out how that pattern is affected. Well, if we look at this, how is it affected? Well, the pattern was over 1 up 1, over 2 up 4, over 3 up 9, over 4 up 16 when I count from the vertex, all right? Basically, we multiply this by whatever that leading coefficient is. So if that was a 2, then the pattern all of a sudden became up 2, up 8, up 18. When it was a 3, the pattern became up 3, up 12. It would be up 27. When it was a 1/2, 1 times 1/2 is a 1/2. 4 times 1/2 is a 2. 9 times 1/2 is a 4.5. We basically change the pattern by multiplying those heights by whatever that value out front is, okay? And so that's going to help us start to graph these things without the XY chart, okay?